Here we have an expression. We need to evaluate its limit as x approaches 1. All we have to do is wherever we see x, we have to put 1 in its place, and whatever real number we get, that is going to be our answer. But then in case if you do not get a real number, instead if you get something like this, 0 by 0 or infinity by infinity, then we have to go to the next step of trying to simplify it or rationalizing it. But that is the next step. First, let us see if we get a real number. Put wherever you see x, put 1 in its place, then what do you get? Unfortunately, we end up with this form. We end up with a 1 minus 1 by 1 minus 1, which is 0 by 0. We end up with an indeterminate form. Then what do we have to do? We have to think about some rule, or we have to try simplifying it. Now, what rule comes to your mind? What about this one? When your x approaches a, doesn't this look familiar? Instead of a, we have a 1, and instead of x, let us take square root of x. But then a very important word of caution. This sort of expression, when you work on this expression, it is when x approaches a. If you are going for square root of x, make sure to change the limit also. If x approaches a, then the square root of x will approach square root of a. Here, obviously, it will not make any difference, because the square root of 1 will be 1 itself. Here, it will not make any difference. But if you are going for numbers like 2 or 5, please remember you have to change the limit also. Now will it work? Let us try. This is the expression that we have. When x approaches 1, then square root of x also approaches the square root of 1, which is 1 itself. Now, can we apply it? No, there is a big problem there. Look at this term. It is an a. It is a constant. It is totally independent of x. But here we have an x. So what do? Let us take that out and see what happens. Okay, so now are we good to go? Now can we apply this result? We have an x minus a constant here. You have an x minus a, but then still we have a problem with this. What problem is that? Here x raised to n is expressed in terms of x. So here we have to express this term in terms of square root of x, or in other words, in terms of x raised to half. So that is going to be our second step. This x into x into square root of x is what? It is x raised to 3 by 2, right? So I have expressed in terms of square root of x. Okay, so now finally we are in this form. What do? We will split the limit. This is the product of two expressions. Let us split them. And not just for product, even for sum and difference, you can split it. The answer that we were looking for is 3. So that is all for today. Assalamu alaikum.